All right, guys, welcome to PreCalculus. This is 1.1.1. So we're going to kind of bypass the very initial part of this. We're going to try and kind of do our best. This is much more of a kind of introductory kind of group team building kind of lesson. We're going to do as much as we can, really be fairly short because we're only going to be doing the parts that we can kind of do by ourselves with this kind of current medium. So to start off here, this is, again, 1.1.1. So we're not going to be doing that. So I'm going to kind of do this for us. I have in front of me a few different types of function. And what we're going to be doing is we're going to be trying to line them up into a continuous kind of function here. And then we're going to try and determine some kind of a actual story for what might happen here. So it may seem kind of silly when you're first doing this, but really the kind of goal is to try and relate a graph to a real world situation. So it's a very important skill. It's just kind of a very light-hearted, maybe seems a little bit silly of a way to kind of introduce it, but it actually is pretty good for us. So I have in front of me here our different functions which we can use here. So you've probably seen some of these in the past, and again, we can kind of turn them. So if you want to do this on your own, I'd recommend just kind of pause it and kind of draw your own out. You can come up so that you can move them, or just kind of draw it on a little piece of scratch paper. That's fine too. So we have, you probably noticed the parabola, the parabolic function. We have an absolute value function. Those are the kind of V-shaped ones. This is an exponential. It's actually an exponential decay. If I have it like this, I could turn it like this, make it exponential growth. It could also be logarithmic or square root. It's kind of versatile in that response there, but again, you can kind of turn it however you want. And the last one here is one you've probably not seen a ton in math classes. This is a sinusoidal function, or a sine function more commonly. We're going to be doing these a lot more later on in the year, but this is your kind of first time really seeing it. But what we're going to do is we're going to try and line these up in any way that you want. And you don't have to follow mine. You can do whatever you want, or you can just copy down what I just did here, right? Whatever you kind of want to do. So once you have a function, so it's kind of one continuous curve the entire way, what you want to try and do is create a story that would give you this actual graph, right? Now, once you do that, you want to define screw this down a little bit so you can kind of see my hand better. You want your y-axis, so my pointer finger here, you want to define what your y-axis is, and then, hey, what's your x-axis going to be for this story too? Now, if you're having a hard time, I'd say, hey, make your x-axis time and make your y-axis something there. So like maybe your y-axis is how much money you have, right? So you're spending money on things, and then you get start to kind of save your money, and then start to kind of spend money for quite a while, and then you get a job, so you start to earn money pretty fast, and then you lose the job, so you start to lose that money. Things of that nature, or you could do altitude, right? So you're going on a hike, you go on this downward path one, and you go on an uphill portion for a while, and things of that nature. Altitude is probably the easy one because it looks like a hill, right? But you could also try and take this into distance from home. You could do any number of things, and you can also change the x-axis if you would like to. So whatever you want to try and think of, rearrange these however you want, draw it out, draw your x and your y-axis, and then kind of label those. And then I'm not going to force you to actually write out what the actual story is, but in your head kind of write a story of what would cause this to happen given my x and my y-axis, right? It's a very important skill for us to kind of have, going from real world situations to graphical representations. That's what we're trying to kind of build and use here. So go ahead and pause the video, do that real quick, and then hop back here and we'll finish this out. All right, so hopefully you're back and you've written your little stories or said your stories to yourselves. We typically share those with our teams, but we're going to kind of bypass that for obvious reasons. So function-wise, these are our notes. Sorry, I haven't mentioned how we do these yet. When our section has notes, I'll kind of point it out. I'll maybe go over a few things here. What I recommend you kind of do is on your own during homework, just read through it. A lot of it's going to be stuff you already know or you kind of get, and if that's the case, you already know it, you're done, keep on going. If there's little bits in there that, hey, I remember hearing that, but it's something that I always forget, write it down and put it in your notes, right? Your notes are for you. I will never check them because they're not my notes, they are your notes. So take whatever notes are going to be helpful to you. I will occasionally, though, kind of go through parts of this. Sometimes I might just kind of say, hey, here's notes, read through them if it's kind of more of a not as important things, or I might do what I'm going to do here and just kind of go through the key parts. So functions, you've been hearing and seeing about functions like for all of your math lives. It feels probably more since like 6th grade-ish. A few ways that we can see them. We've seen them in equations. We've also seen them in tables and then also in graphs. Those are kind of the main ways. There are other ways, but those are the kind of main ways we've kind of seen. We have these little function machines that we plug in an input, do what it says. Here's the operation, and you get an output out of it. You have dependent and independent variables. Your dependent variable is what its value depends on what the independent is. So that's your output typically, whereas your independent is your input, because that can be whatever you plug it in, and then what you plug in determines, hence the dependent, what the dependent variable, which is typically your y is. Kind of goes over some function notation. Again, you've seen that for quite a while. I'm not going to go too much into that. Domain and range, you've seen or heard those terms for years now. Domain, again, is all your possible inputs or your possible x's. Range is your possible outputs or your possible y's, right? We are, in this class, going to start to kind of see non-functions and actually start to work with them. You've primarily only seen functions thus far because you can do a whole lot more, a lot more easily with functions than non-functions. But we're going to get to the point where we start to actually work with non-functions. It's a lot harder, and you can do a lot less things. We're not going to spend a ton of time on it, but we will start to see more and more non-functions. Like the first one here, a circle. Here is the equation for a circle. Here's a fairly small, not very helpful table for a circle. Then here's the graph of that circle. So that's, again, circles are common and useful shapes, but they're not functions. So we still need to kind of know how to work with these non-functions. So we are going to see that later on in the year as well. All right, and then our closure here today. So again, just kind of rethink to your actual story, your graph there, and which types and shapes of a curve related to what was happening in your actual story. Just kind of answer that question in your head really briefly, and then we'll move on here to the homework. So homework, we're just doing problems 5 and 6. Now 6 is a fairly long problem, hence why you're only seeing 2 things for your homework. Rather than me print you all off these little sheets, it's just easier for me just to give you this little template. And I don't really care how you organize it, but you can organize it like this if you prefer. We're going to be trying to kind of make a little kind of card or a little area or a little cheat sheet for all these different parent functions and families of functions. So I've got a number of things here that we'd want to take a look at. So the parent graph family. So we'll do one really easy. We're going to talk about parabolas, right? So the parabolic or quadratic, however you want to kind of label it, whatever kind of makes the most sense to you and you think of when you see those. The equation. So you kind of want a base one here. So the base equation would be f of x is equal to x squared. That's the parent one there. And then we want to make a table of that, and then you want to do a quick little graph, and then you want to state the domain and the range, and then you want to state the locator point. Locator point is one that always kind of throws people off because it's not something that we go over really in depth in any course. I expect you to do it like a little bit here and there, but most of our teachers don't because it's not terribly important, but you have used it, you just may not have known. So the locator point on a parabolic graph would actually be the point 0, 0. As we're going to, right there, because that would be the vertex of your parabola. And then any kind of shifting we would do with that, you would typically do it from that locator point. So if I said, hey, this is a parabola that's been shifted 2 right and 5 up, you would typically go here and then go 2 right and 5 up from there and then put your vertex there. So your locator point is just whatever point you would typically do that with. For most graphs, it's going to be 0, 0 if your graph goes through there. But other things like exponentials don't, so it might be a little bit off of there. if you're having a hard time with the locator point, don't worry about it. If you can get everything else here, you're totally fine. So with that, try your best on that, and I will talk to you guys next time.